Applications of ratio and percent. In this lesson, you will use proportional relationships to solve ratio and percent problems.
Introduction. Understanding proportional relationships, like we learned about in the last lesson, can help you solve the ratio and percent problems that pop up in everyday situations. For example, you can use proportional relationships to calculate price discounts and markups, sales commissions and interest rates, taxes and tips. You can also use proportional relationships to solve problems involving a percent change in a given quantity and percent errors in measurements and calculations. In this lesson, you will use proportional relationships to solve ratio and percent problems.
Solving ratio problems. If two ratios, A to B and C to D, are in a proportional relationship, then A over B equals C over D. You can use this equation to find an unknown value in a proportional relationship if you know the other three values. Let's look at an example. Ryan is conducting a wildlife survey for his science class project. He discovers that the ratio of tigers to lions at a popular national park is 3 to 4. There are 24 lions in the park, but he doesn't know the number of tigers. He can find the number of tigers, the only unknown quantity, using the three known quantities. Suppose the park has X tigers. The ratio of tigers to lions is 3 to 4. The actual number of tigers to the actual number of lions is X to 24. These two ratios must be equal. So, number of tigers over number of lions equals 3/4 equals X over 24. To find X in the equation 3/4 equals X over 24, we first get rid of all the denominators. We can remove the denominator 4 from the fraction 3/4 by multiplying both sides of the equation by 4 over 1. 3/4 times 4 over 1 equals X over 24 times 4 over 1. 3 equals 4X over 24. Next, we remove the denominator 24 from the fraction X over 24 by multiplying both sides of the equation by 24 over 1. 3 times 24 over 1 equals 4X over 24 times 24 over 1. 3 times 24 equals 4X. 72 equals 4X. X equals 72 over 4. X equals 18. The value of X is 18. There are 18 tigers at the park. Cross multiplication. Another method, called cross multiplication, is a quicker method for solving ratio and percent problems. To cross multiply two fractions, we multiply the numerator of each fraction by the denominator of the other fraction. The resulting products are equal. Let's use cross multiplication.
So real quick, I'd like to show numerator, denominator. So in the numerator and denominator, the numerator enumerates or counts how many of the denominator there are. So numerator. The fraction bar separates the denominator and the numerator. It is a symbol for division. So A over B is the same as A divided by B. The denominator is the part of the whole that is being counted by the numerator. So if we have 1 out of 4, we have 1/4. I also use the memory cue of D is down.
To solve Ryan's problem and find the number of tigers in the park. We will multiply the numerator of each fraction by the denominator of the other fraction. Number of tigers over number of lions equals 3/4 equals x over 24. 3/4 equals x over 24. 3 times 24 equals 4 times x. 72 equals 4x. X equals 72 over 4. X equals 18. Notice that 18 is the same answer we got earlier. Each month, Stacy places a portion of her earnings in a retirement account. Her savings are invested in 2 companies. For every $9 invested in Company A, $2 is invested in Company B. Stacy quizzes her children, Krista and Kevin, about how much money she will invest in Company A if she invests $24 in Company B. Krista approaches the problem using the first method from this section, while Kevin uses cross-multiplication to find the answer. Next, you'll find out who answered Stacy's question correctly.
So, directions. Read the instructions for this self-checked activity, type in your response to each question, and check your answers at the end of the activity. Write a brief evaluation of your work. Activity. Each month, Stacy places a proportion of her earnings in a retirement account. Her savings are invested in 2 companies. For every $9 invested in Company A, $2 is invested in Company B. Stacy quizzes her children, Krista and Kevin, about how much money she will invest in Company A if she invests $24 in Company B. Krista and Kevin used 2 different methods to arrive at the answer to Stacy's problem. Let's see who found the correct answer and how. What is the ratio of the amount invested in Company A to the amount invested in Company B? Write the answer as a fraction. Well, for every $9 invested in Company A, $2 is invested in Company B. Think of this as an automatic thing. So that's $9 for every $2 in Company B. We can check our answer. The ratio of the amount invested in Company A to the amount invested in Company B is 9/2. Part B. What is the ratio of the unknown amount, X, invested in Company A to the known amount, 24, invested in Company B? So, amount X invested in Company A to the amount B if 24 is invested in B. All right. So, we know that X, the unknown amount in A, to 24, the amount in B. We can check our answer. The ratio of the unknown amount X invested in Company A to the known amount $24 invested in Company B is X over 24. X over 24. The ratios from part A and B are equivalent. Write an equation by setting the ratios equal to each other. So if the ratios from part A and part B are equivalent, we're going to write the equation by setting the ratios equal to each other. Remember, with equivalent equations, you can put the 2 expressions together into a single equation. So this was the initial expression, and this is the second expression. And then we set them to be equal to each other. And you can check your answer. 9/2 equals X over 24. So study the equation from part C. What operation must you perform to both sides of the equation to get X by itself on the right side. To isolate x, or to get the variable alone on one side of the equation, what do we have to do? Well, since 24 is here and we want to get rid of it, it's x divided by 24. To undo, we do the opposite operation. So the opposite of divide by 24 is multiply by 24. We can also multiply 24 over 1, because if we look at our calculator soup and our fractions calculator, we can see that it's the same thing. We've talked about that. This is what it looks like when you write it out. 24 over 1 times 9 over 2 equals x over 24 multiplied by 24 over 1. These cancel out the way we've shown it before, and then you're left with x on one side of the equation and then this problem. Stacy's daughter Krista used a method shown in part D to solve for x. She isolated the variable x on the right side of the equation. Using this method helped Krista solve for x in the equation 9 over 2 equals x over 24. Show your work. It's not as easy as it looks on these tutorials because you have to use all the little equation editors to make it look like this. I am doing a shortcut. I am using the just the slash mark. So we start with 9 over 2 equals x over 24. I'm using calculator soup to show that multiplied by 24 over 1, the 24 over 1 cancels that out. We talked about that. And then 24 over 1 times 9 over 2, I used calculator soup. And 24 times 9 is 108. Excuse me, I misspoke. 24 times 9 is 216. Divided by this 2 equals 108. When Stacy's son Kevin solved the problem, he changed the equation from part C to one that didn't have any fractions. In other words, he eliminated the denominator on both sides of the equation. Explain how to get rid of both denominators in the equation. So if the equation is 9 over 2 equals x times 24, the first step I'm going to do to get rid of the 2 is to multiply by 2. It's divide by 2 currently, and to get rid of it, I'm going to multiply by 2. So I need to multiply both sides by 2 to get rid of this denominator. Once you've done that, then to get rid of this denominator, you need to multiply by 24 to both sides. X divided by 24, you undo it by doing multiply by 24. Using the method described in part F, help Kevin change 9 over 2 equals x over 24 to an equation without fractions. Show your work. Don't solve for x yet. You'll complete that in step H. It is really challenging for me to go only step by step. So we write down the fraction, 9 over 2 equals x over 24. And the next step is going to multiply both sides by 2. So multiply both sides by 2, which is the same as saying 2 over 1. So 2 over 1, 2 over 1. Multiplying by the 2 over 1 eliminates this divide by 2, and it makes the multiply by 2 over 1 go onto that side. What you do to one side, you have to do to the other. Remember, use calculator soup to help you. After you multiply 2 times the x, and it becomes 2x over 24. And when you cancel out the 2 over 1 times the 9 over 2, you're left with just the 9. Next is to do the same thing with the 24. So that way we get rid of the 24 from the right-hand side. So you multiply both sides by 24. 24 times 9 equals 2 times x, or 2x. Again, the multiplying by the 24 over 1 cancels out this 24 right here. If we show our sample answer, you can see the steps in a little bit cleaner format, leaving us with 24 parentheses 9 equals 2x. That's the same as 24 times 9 equals 2x. In mine, I have 24 in the parentheses. Doesn't matter, same thing. Okay, in part H, the method you use to help Kevin in parts F and G is called cross multiplication. It's called cross multiplication because it involves multiplying the denominator of each fraction with the numerator on the opposite side of the equal sign. So the 24 goes up over here. The 1 over here goes over here. 1 times 2x, like that. Now solve the equation 24 times 9 equals 2x. So we have 24 times 9 equals 2x. I do the 24 times 9 is 216 equals 2x. Then we divide out the 2 to get rid of that. We divide by 2 on this side because we canceled it out over here. We are left with 216 divided by 2 is 108. X. 108 equals x, or x equals 108. This shows it a little bit cleaner. The divide by 2, that was a little unclear up there. Who answered Stacy's question correctly, Krista or Kevin? Based on the proportional relationship given, how much money will Stacy invest in company A if she invests $24 in company B? Well, both Krista and Kevin found the right answer to Stacy's question. Stacy will invest $108 in company A, and if she invests $24 in company B. You can check your sample answer. Self-evaluation, how did you do? Write a brief evaluation. What challenged you?
You've seen how to use cross multiplication to solve problems involving ratios and proportions. The general form for cross multiplying is A over B equals C over D. A times D equals B times C. Next, you'll apply this method to solve a problem involving a proportional relationship.
Select the correct answer from each drop-down menu. Hank is building a dog run for his dog. He wants the ratio of the length to the width of the dog run to be 5:2. These two dots, the colon there, semicolon, sorry, is 5:2. That's how you read that. If he builds the dog run so the length is 10.5 feet, Which equation can be used to solve for the width, W? What is the value of W? Okay, so in order to solve this, you need scratch paper. Okay, you can't just pick one of these and move on. So what I did was I got a Google Doc and I'm using that so you can see my thought process. So the length to width ratio is L to W, 5 to 2. That's given information. If L is 10.5 feet and we follow this ratio, what is the width? That's what they're asking. So 5 to 2 equals 10.5 over W. Now we know this because 5 to 2 is given. And we look at the each expression and put them together in equivalent, use equivalent equation because of the proportional relationship. So how do we then undo this and get one of those answers? So divide by 2, we multiply by 2 here to get rid of this 2 here. So 10.5 over W multiplied by 2 over 1. See the calculatorsoup.com to see how that works. So then we're left with this 5 here. 10.5 times 2 is 21 over W. If you're worried about that 1 gets multiplied by a W and it's still just 1W. So then we want to get rid of the W on this side to get the variable by itself. So in order to undo divided by W, we multiply by W as shown here. So that would cross that out and do the same to the other side. W times 5. 5W equals 21. Now we need to get rid of the 5 to find just the width. So we divide by 5. 21 divided by 5 is 4.21. So what the width equals 4.21 feet. Now, let's see which answers work for that. So we got the answer 4.2 feet for width, and the equation to solve is 5W equals 2 times 10.5. All right, we got that correct. The explanation down here is pretty helpful, and because they're doing it and not on scratch paper, they can write it out a little more cleanly.
Solving percent problems. You can use cross multiplication to solve not just fraction problems, but percent problems too. Let's look at an example. Peter bought a soccer ball for $20. He paid an additional 10% sales tax. What is the total amount Peter paid for the ball? A percentage can be expressed as a fraction with 100 as its denominator. A tax of 10% written as a fraction is 10 over 100. That means the tax would be $10 on a $100 purchase. Let's find out how much tax Peter paid on his $20 purchase. If T is the tax amount, then tax percent over 100 equals tax amount over price. 10 over 100 equals T over 20. Use cross multiplication. 100 times T equals 20 times 10. 100T equals 200. Divide both sides of the equation by 100. 100T over 100 equals 200 over 100. T equals 2. So, the tax is $2. Peter paid $20, the price, plus $2, tax, or a total of $22 for the soccer ball. Quantities are often expressed together as a total. If you know the total and the percentage of the total for each quantity, you can calculate each of the quantities. This method is helpful in many contexts that involve percentages, such as calculating interest rates, taxes, tips, discounts, and price markups. In the next activity, you'll apply these ideas about percentage to calculate just how many strands make up a set of pom-poms.
Directions. Read the instructions for the self-checked activity, type in your responses to each question, check your answers at the end of the activity, write a brief evaluation of your work. Activity. A pom-pom manufacturer makes each of its pom-poms with 35% white strands, we'll say that's W, 25% blue strands, we'll call that B, and 40% red strands, we'll call those R. If each pom-pom has a total of 80 strands, how many strands of each color are needed to make a pair of pom-poms? In this activity, you'll work through this pom-pom problem step by step. Let's go. Give me a part A. Write a proportion for the number of strands in each color to find how many strands are needed to make one pom-pom. So the white strands is W over 80. The number of strands that are white over a total of 80 strands. That is the same as what over what? So the first step I did was to copy these down in these examples into the box here so that way you could see white over 80 equals what over what? Blue over 80 equals what over what? And red over 80 equals what over what? So now we are going to look at the percentages and solve this out. Well, we know that percent means part of 100. Part of 100. So that means the number of white strands out of 80 is 35 out of 100. 100%. It's 35 out of 100. That information is given to us right here. 35% means 35 per 100 strands. Well, we don't have 100 strands, so that's why it's a percentage. Blue over 80 equals 40 over 100. Again, that's given here. Blue strands. Oh, I'm sorry. Let me pause for a second. Okay, I apologize. I misspoke. The white one is 35%, which means 35 over 100. The blue is 25% of the pom-pom strands, which is 25 over 100. The red percentage is 40%, which is 40 over 100. So we're taking the expression and the other expression and making an equivalent equation out of it. All right. So this is a proportion for the number of strands in each color to find how many strands are needed to make one pom-pom. Note to self, 1. So solve for W, B, and R using the proportions from part A. Show your work. So now that we have these proportions here, we can now solve for it. So taking one at a time and working it through. So if the number of white strands out of 80 is equal to 35 out of 100, or 35%, we can then multiply by 80 to get rid of it and to get the W by itself. We do both sides multiplied by 80. So white equals 35 over 100 times 80 over 1. Again, use calculator soup. So 35 multiplied by 80 divided by 100 equals 28. 35 times 80 divided by 100 equals 28. Again, use calculator soup if you need help with that. You can multiply that whole fraction out using calculatorsoup.com. Now, as my form looks a little bit different, but here is how it looks played out on the sample answer. Okay. So then, once we have that, we need to look at the equation for the blue strands. Now, I didn't mess up and call the blue strands a different percentage this time. So the blue strands is the number of blue strands out of 80 equals 25%. Again, same exact process. Multiply by 80 to both sides. We get B by itself. 25 times 80 divided by 100 is 20. So the number of blue strands out of one pom-pom is 20 strands. Okay, then the next step is to do the exact same thing with R, with the red. And this is why scratch paper is really handy. So you do it on scratch paper and then you add it into here. So red over 80, multiply by the 80 to get rid of this, multiply it against both sides. It's the equivalent of 40 over 100, multiply by 80 over 1. That's the same thing. R equals 32. 40 times 80 is like 3,200, divided by 100 is 32. So now we know how many strands of each color are in one pom-pom. Okay, so we can look at the sample answer. White equals 28 strands. There are 20 blue strands in one pom-pom and 32 red strands in one pom-pom. Part C, how many strands of each color are required to make a pair of pom-poms? So, this may seem relatively simple. It is. All we are doing is multiplying the answer by 2. However, so 28 times 2, because 2 are in a pair, so 2 pom-poms in one pair, right? Times 2 pom-poms equals pom-poms in a pair. So 28 times 2 is 56. 20 times 2 is 40. 32 times 2 is 64. Now, you can solve the problem in part C a slightly different way. The total number of strands required to make one pom-pom is 80. So 2 pom-poms is 80 times 2. That's all. Okay, so we set it up. Now, part E says, look, solve for W, B, and R for a pair of pom-poms. Very important that we know. All right, solve 3 proportions similar to the work you did in part B. So I'm not going to go through it exactly the same, but the steps are exactly the same. But instead of 80, right, instead of out of 80, it's 160 to 2. So white, the number of strands in a pair of pom-poms of white strands is out of 160. And it's still the same percentage, 35 over 100, 35%. So we multiply out the 160, multiply out the 160, do it to both sides. We're left with W equals 35 over 100 multiplied by 160 over 1. Trust me, use calculator soup, that equals 56. We do the same steps for B and R, so for the blue and the red. Part F, did you get the same answer? Yes, we did. Red is 64, blue is 40, and white is 56. Self-evaluation, how did you do? What issues did you have?
Discounts. In the activity, you use percentages of quantities in a proportional relationship to find individual quantities. You can also use this method to calculate price discounts and markups. Discounts are expressed as a percentage of the marked price. Let's calculate the amount of a discount. Lena wants to buy a pair of shoes. The marked price of the shoes is $60, but the store is offering a 40% discount. We'll help Lena calculate how much money she needs to buy the shoes. Let the amount of the discount be D. Discount percent over 100 equals amount of discount over marked price. 40 over 100 equals D over 60. Cross multiply. 60 times 40 equals D times 100. 2,400 equals 100D. Divide both sides by 100. 2,400 over 100 equals 100D over 100. D equals 2,400 over 100 equals 24. The amount of the discount is $24. The discounted price is the difference of the marked price and the discount. 60 minus 24 equals 36. Lena should plan to pay $36 for the shoes. Percent increase and decrease. Quantities, such as prices of items and other measures, often increase or decrease. Understanding percent change, increase or decrease, gives you an idea about how much the quantities have changed. We can use cross multiplication to understand percent change. Percent change equals amount of change over original amount times 100. To find a percent change, you can rearrange the quantities and the formula. Percent change over 100 equals amount of change over original amount. The amount of change is the difference of the original amount and the new amount. Amount of decrease equals original amount minus new amount. Amount of increase equals new amount minus original amount.
So it's very important that we are aware of what we are solving for before we try to set up our problem. And if it doesn't sound right or look right, it probably isn't.
Let's look at an example of how to calculate percent change. Last year, Joe earned $10,000 working part-time at a craft store. This year, he's going to earn $12,000. Let's find the percent increase in his earnings from last year to this year. First, we find the amount of increase. Amount of increase equals new amount minus original amount equals 12,000 minus 10,000 equals 2,000. We plug the amount of change and the original amount into the formula. Percent change over 100 equals amount of change over original amount. Percent change over 100 equals 2,000 over 10,000. Use cross multiplication. 10,000 times percent change equals 2,000 times 100. Percent change equals 200,000 over 10,000 equals 20. Joe's salary increased 20% between last year and this year.
Question. Select the correct answer. Eden bought a new phone. The phone's retail price is $199. In addition, she paid the sales tax of 8% of the retail price. A few days after the purchase, she filled out a mail-in rebate form and got back $50 from the store. How much did Eden pay for the phone after tax and the mail-in rebate? Again, I need a, oops, try again. Again, I need a piece of paper to work this out. So $199, she paid 8% of the sales tax of the retail price. So that is the tax over 199, which is equal to 8 over 100, 8%, 8 over 100. Sorry, I don't know why my screen shifted like that, which is the same as saying 100 plus 100 times 0.08, which equals $214.92. Then we minus the $50 rebate, it equals $164.92. I'm going to show you the cross multiplication method in the sample answer. Hey Siri, what is 8% of 199?
8% times 199 is 15.92.
Okay, so that's 15.92. Hey Siri, what is 15.92 plus 199?
15.92 plus 199 is 214.92.
Hey Siri, what is 214.92 minus 50? Hey Siri, what is 214.92 minus 50?
214.92 minus 50 is 164.92.
Okay, so we can use our calculator or the tools that we already have in our pocket to solve these questions. Now, notice that the possible answers here are 214.92. That was one of the answers we got, but that only includes the sales tax. It doesn't include the mail-in rebate. So we have to actually subtract that from the 214.92. This happens when we get ahead of ourselves and get tricked and don't finish the problem all the way out. So this shows the cross multiplication process.
Percent error. We can calculate the percent error in measurements and calculations by applying the principle of proportional relationships. Watch the video on the next screen to learn about solving problems that involve percent error.
And welcome back, folks. What's going on here is an unprecedented ruling on the placement of the football.
In case you're just joining us, Ulysses O'Hanrahan of the O-Town Ocelots threw the ball to Stooge Nescobar on a 3rd and 29.
And Nescobar almost took it to the house for the touchdown.
It looks like he was brought down about 6 inches from the goal line from my vantage point.
Here's the unprecedented part, folks. The placement is so close to call that instead of the traditional yard marker chains, or what have you, the referee is actually out there with the ruler to measure exactly how close Nescobar got to the goal line.
Again, rounding to the nearest inch, I'd say Stooge is 6 inches shy of a touchdown.
Well, I believe that's why they're using the ruler. You're estimating, and that doesn't always give an exact number. Let's go to the Super Zoomy Cam for a closer look. The actual measurement is a decimal number. Yeah, you can see it right here. That Nescobar is actually 6.25 inches away from the goal line.
Love that Super Zoomy Cam. I estimated the ball was 6 inches away, but the actual measurement, measured by a ruler for the first time ever in a football game, mind you, is 0.25 inches off of my estimated measurement. I feel like a failure of a football announcer.
Don't be so hard on yourself. There's a percent error, which is how far off your estimate was from the actual answer. This percent error is a percentage of the actual answer.
While we wait for the referees to deliver their ruling, how do I find this percent error?
We can set up a proportion so that the ratio of the error to the actual measurement is equal to a value over 100. Here, 0.25 over 6.25 is equal to x over 100. The value of x is the percent error.
Okay, so if I cross multiply, I get 6.25 times x is equal to 0.25 times 100. So 6.25 times x equals 25. Divide both sides by 6.25 to find that x equals 4.
That's right. That means there was a 4% error. Your estimate was only off 4% from the actual answer.
Fantastic! I feel better already. But it looks like the Ocelots won't feel better. Here comes the official ruling.
After further review, with a ruler from my grandson's backpack, the ruling on the field is that the offense is now 6.25 inches from the goal line. This will be first and goal, as well as 20 minutes of my life I will never get back.
Well, how about that?
I'm just glad they got it right. Now, we can get back to the football game. But first, a word from our newest sponsor, Gridiron Rulers. In a game of inches, don't get caught with the large percent error. Get the actual measurement with Gridiron Rulers.
The Ocelots just scored a touchdown in the time it took you to do that read.
All right. Summary. Knowing how to solve proportional relationships for an unknown quantity when there are 3 known quantities can help you with many types of problems. If 2 ratios, A to B and C to D, are equivalent, then AD equals BC. Using the formula, you can solve percent problems involving interest rates, taxes, tips, discounts, and so on. I've never used it to solve for percent error. I don't know. You can also calculate a percent increase or decrease from a quantity by using this formula and cross multiplication. And you can use the same method to find percent errors in calculations and measurements. Congratulations, you've completed the tutorial, Applications of Ratios and Percent. Good luck on your mastery test. Remember, use scratch paper. It's cheaper than your education. Cheers to your greatness.